absolute value equations follow this rule. We've got some absolute value symbols going on in an equation. So the rule is for a is greater than 0, the absolute value of x equals a means x equals a or x equals negative a. So, and this could be more than just x in the absolute value. It could be things going on here. But once you have the absolute value symbols isolated, go and go to that, isolate the absolute value part first. So first we have to isolate the absolute value part. Then once we do that, we could set whatever that is equal to the positive or the negative. Okay, so for example, if I have the absolute value of x equals 3, let's think about, and start with a really basic one to see that this makes sense. What's going to make this equation work? It works if x equals 3 or if x equals negative 3. Because the absolute value of 3 is 3, absolute value of negative 3, that also is 3. Okay, so both of them work, so we get two different answers. So let's do some where they get a little longer. I'm going to go back to this one in a minute too. So, and if the rule, sometimes it makes more sense to, maybe I'll jot it down over here. Absolute value of x equals a. The rule is that then you split it up to x equals a, x equals negative a. And it's maybe a little more visual than just the definition in a straight line. Okay, so how about 2 absolute value x plus 2 and my absolute value minus 5 equals 9. Okay, so notice I can't use my rule yet until I get this absolute value of x plus 2 alone first. So if I add the 5 over, 2 absolute value of x plus 2 equals 14. Divide by 2 on both sides. Absolute value of x plus 2 equals 7. So now the absolute value part is alone. I can split it up. X plus 2 equals 7, and x plus 2 equals negative 7. Notice, I don't do anything to the left side. Both of those come down, drop the absolute value, set it equal to the positive and the negative. So that means x equals 5, or x equals negative 9. So let's do a little check, see if those both work, or how that's possible. So I'd have 2 absolute value, 5 plus 2 minus 5. Is that 9? Well, that's 7. Positive 7 times 2, 14 minus 5. Yep, that one checks out. How about the negative 9? Negative 9 plus 2 minus 5 equals 9. So now that's absolute value of negative 7. 2 times a positive 7. Once I do the absolute value, minus 5. Yep, that checks out too. That's 9. So notice, it's going to get me the positive and the negative of the same number, which means it's going to work out 2 different times typically. These are my answers. Okay, one more. How about the absolute value of x and the absolute value symbol plus 7 equals 2. So minus 7 on both sides. Absolute value of x equals negative 5. So right now, my rule doesn't work, because this rule was only when a is greater than 0. Let's say I didn't realize that though, and I kept going. Maybe I said, okay, well x equals negative 5 and x equals positive 5. And let's check it out. Absolute value of negative 5 plus 7. Is that 2? Is 5 plus 7 2? No. Or absolute value of 5 plus 7. Same thing. Is 5 plus 7 2? No. So notice, it doesn't work when we have a negative. There's not going to be a solution. So that means this would be no solution, this answer. Okay. So only works if it's a positive. But we get it equal, the absolute value part equal to negative, no solution. If you want, you probably could even add to the little rule. If a is less than 0, then there is no solution. Okay, so let's go back real quick, and let's graph each of these to see what they look like. So our different examples, we had absolute value of x equals 3, and then we had 2 absolute value of x plus 2 minus 5 equals 9, and then we just did absolute value of x plus 7 equals 2. Now first I'm going to rewrite them so I can actually put them into the graphing calculator or Desmos, whatever you're going to use. Switch this to absolute value of x minus 3, because that's like it's equal to 0, equal to y. What we're interested in is where are we crossing the x-intercepts. So this one, if I move the 9 over, I'm going to have 2 absolute value of x plus 2 equals, minus 14 equals 0. I'll just have to put this in. And then the last one, absolute value of x plus 5. Hopefully, you know that a basic absolute value of x is like a v starting at 0, 0. So that's what the basic one looks like. So when I do minus 3, that means down 3. And notice my x-intercepts 3 and negative 3. That's how we got both of those answers. I'm going to jump in, how about the plus 5 one? So now I'm going to jump to the last example we did. So the plus 5 one, notice how it goes up 5. So notice how it doesn't cross the x-axis. So we had gotten no solution. So that's why, because we don't cross the x-intercept at all. There's nowhere where if y is 0 that we're going to get an x. And then the last one we did, we had 2 in front, and then x plus 2 in the absolute values, and then minus 14. Okay, so that one was moved around a little more than just up and down. It looks like it became steeper. It got moved to the left and down, and notice my intercepts are 5, 0, and negative 9, 0, which those were the answers we had gotten.